I proceed?
Boleh.
Okay. So, okay, before this we learn about constant deceleration. Okay, so this subchapter kita tengok kepada deceleration with wind resistance. Okay, with wind resistance. Okay, the aerodynamic drag on a vehicle is dependent on the vehicle drag factors and the square of the speed. Ini the equation lah. Summation of force at x-axis equal to Fb plus Cv square. Okay, Fb is the total brake force at front and rear wheels. Okay, and C is the aerodynamic drag factor. V of course is the vehicle punya velocity. Okay, so same case macam constant deceleration tadi, how to determine the stopping distance and so on. Okay, so you must integrate lah. Integrate, tapi dia ada quite complicated sikit. Sebab dia ada yang fx ni kita gantikan dengan equation ni. Sebelum ni fx ni just fx saja. Just fx saja. Tapi dia ada elemen total brake force and drag factor, aerodynamic drag factor. So to determine the stopping distance, okay, you must integrate based on this equation, and finally you get this formula. Okay. Next, sini. Okay, and then we go to the energy or power in terms of deceleration. Okay, the energy and power absorbed by a brake system can be substantial during a typical maximum effort to stop. Okay. And then the energy absorbed is the kinetic energy of motion for the vehicle that can express as this equation that depend on the mass, vehicle mass. Okay. Energy absorbed during the braking phenomenon can be expressed by this equation, and this energy is depend on the mass of the vehicle. Okay, and then when we talk about power absorption, okay, the power absorption also will vary with the speed. Vary with the speed, being equivalent to the braking force times the speed at any instant of time. Thus, the power dissipation is greatest at the beginning of the stop when the speed is highest. Okay, so maksudnya power dissipation ni greatest at beginning of the stop. Bila nak tekan stop, power absorb tu mesti lebih kuat. Bila mana speed tu at the of course, so for example, you travel at 100 km per hour. You want to full stop the car, so you press the brake pedal heavily. Okay? You tekan emergency brake kan. You tekan kuat pada brake pedal, and then of course the power dissipation tu is the greatest. Okay? When you start to stop, or when you begin to stop. Okay, and then the equation we can express as power dissipation as this equation m over 2 times v. This v is the initial punya speed over ds. Okay, instead of before there are three equations, so I need to write down another two equations as display on your screen now. So please write down this equation. Okay, boleh?
Boleh.
Ya, sekarang ni boleh
Boleh cik.
Ada soalan sekarang ni?
Tak ada.
Tak ada Okay. So we go to the next slide. Okay, braking force. So I masuk pada braking force. Okay, braking force. Okay, the force on the vehicle that produce a brake deceleration may arise from a number of sources. Okay, for example, kita akan tengok kepada primary source dulu. Yang source kecil-kecil tu kita boleh tengok kemudian lah. So these are the four primary sources that contribute to the deceleration. Okay. So there are four: rolling resistance, aerodynamics drag, driveline drag, and road slope. Okay, we go to the first, which is rolling resistance. Okay, meaning that the rolling resistance always opposes vehicle motion, hence it aids the brakes. Okay, tu you kena ingat. Maksudnya, contoh, okay, we have a wheel, dia rotate sebelah sini. Dia mesti ada force yang dia always opposes the vehicle motion. Di sebelah sini lah. Okay. And then biasanya rolling resistance ada pada tayar sini. Kat sini. RXF atau R lah. Okay, this is the equation. RXF, this is the total lah. Kita ambil total rolling punya resistance. RXF equal to RXR. Okay. RFX is the rolling resistance force at front axle, front tire. Kalau XR ni ialah at the rear. Okay, equal to FR. Okay, FR is the coefficient, rolling resistance coefficient. Dan kurungan WF is the weight at the front axle plus weight at the rear axle. Okay, equal to FR. W is the total of the weight at the front and rear axle. Okay, normally the rolling resistance force is about 0.01 G deceleration. Meaning that berapa? 0.01 G. We can assume as berapa nilai dia? Macam mana? Respon. 0.01 G. So berapa nilai?
0.0981.
So 0.01 times 9.81 kan? Itu G dia. Dapatlah 0.009. Salah. Berapa?
0.09.
0.09 Okay, 0.0981 Newton. So dia, even it's not too heavy or too big, but it can contribute to the braking punya force. Okay. So this is about the rolling resistance. Okay, next is the aerodynamics drag. Okay, aerodynamics drag. Okay, the drag from air resistance it depends on the dynamic pressure, okay, and thus proportional to the square of the speed. Okay, biasanya aerodynamic drags ni kita assume sebagai zero lah kalau at the low speed. Kan, kalau kita gerak terlampau perlahan, aerodynamic drags ni kita assume sebagai zero lah. Tapi kalau kita speed tu tinggi, kita kena ambil kira aerodynamics drag. Okay, and normally at highway speed around 100 km per hour, it may contribute, meaning that the aerodynamic drag force will contribute about 0.03 G. Maksudnya 0.03 G times 0.03 times 9.81. So dapatlah berapa Newton dia. Okay. Okay. Okay, next we go to the another force that contribute to the braking force, which is driveline drag. Okay, as you learn during last week, kita ada torque punya distribution to the driveline, to the suspension system. Okay, meaning that it comes from the engine for the primary source of the torque, okay, and then it's the flow of the torque of force from engine transferred to the transmission and final drive that contribute to the drag and initial effects of the braking action. The drag arises from bearing and gear friction in the transmission, elevation and engine brake. Okay, biasa ni kita tengok engine braking ni is equivalent to the torque that observed by the dynamometer that arise from internal friction and air pumping losses. Okay, maksudnya di sini bila kita brake, bila kita tekan pedal brake, of course the components such as or systems such as engine will slow down and turn. Bila engine slow down, it contributes to the transmission also kena slow down, and also the final drive and so on. So the drag may rise to the gear friction because of the slowdown, and also from the bearing of the moving part. Dalam engine mesti ada banyak moving part, mesti ada banyak bearing. So sama juga di transmission and also the differential. So the drag may rise from these frictions that occur at bearings, gears. Okay. And then biasanya kalau you ada siapa nak dengar dynamometer, kita ambil subjek engine je. Engine teknologi ke subjek engine yang gunakan dynamometer. Ke ambil SAM ni?
Belum.
Belum kan? SAM ni kot? Automatic tu Belum tak ada Okay, tak apa. So nanti you akan belajar guna dynamometer yang merupakan engine lah. Kita bagi engine dyno. Di short form kita bagi engine dyno. So dia ada term bila kita brake. So the braking fenomena tu kita assume, kita boleh predict. Even the engine dyno, dia tak ada macam apa, sistem kereta betul, tapi kita boleh assume the braking by the braking of the driveline track ni that come may arise from the internal friction and also the air pump punya loss dalam sistem lah, dalam sistem dyno tu. Itu maksud statement yang ketiga ni. Okay, next we go to road slope. Road slope will contribute directly to the braking effort. Whether you in uphill, the term uphill maknanya positive sense, positif punya road slope, theta tu, or negative ataupun you downhill. Uphill biasa ke sini, ke atas, kalau downhill you ke bawah lah, you ke bawah. So there is additional force on the vehicle arise from the road slope, assume as Rg. So this is the equation. Normally for small angle, biasanya theta ni kita boleh assume as that sin theta is W theta. Kalau benda tu terlampau small, too small. And then normally the grade is contribute to the equivalent of 0.04 G punya deceleration. 0.04 G punya deceleration. So based on 4 factors ni, mana yang paling tinggi? Kita tengok kalau this road slope 0.04 G, ni kita boleh apakan lah. Yang nombor 2 is 0.03, number 1 is 0.01. So the most factor is the fourth factor, which contribute to 0.04 G to the braking force. Second ni. So number 2 is aerodynamic legs, and the less is the rolling resistance. Ada soalan cakap ni? Boleh? Ya.
Yang driveline track tu memang tak ada